Today we're going to start our discussion on inverse trigonometric functions. A lot of what we're going to see today is going to be based on a lot of the charts that you have memorized and a lot of the trig values that we've already been working with and determining which quadrant it has to be in order for it to be positive or negative. So before we get into that, we want to just remind ourselves what an inverse function is. So an inverse function, f, is written as f negative 1. It kind of looks like an exponent, but remember it doesn't actually mean f to the negative first power. It's our way of representing the inverse of f. Now if a function has an inverse function, then it is 1 to 1 and passes the horizontal line test. So just as a reminder of what that means, 1 to 1 means that for every x value, there's only one y value, and for every y value, there's only one x value. And if a function has an inverse function, then it's going to pass the horizontal line test. So vertical line test for to see whether or not a graph is a function. If the inverse is also a function, it should also pass the horizontal line test. The original function should pass the horizontal line test. Now, what about inverse trig functions? So the inverse trig functions are not 1 to 1. Okay, so think about it this way. Remember how last lesson, we were talking about finding specific trig values, and for example, sine of pi over 4 in the first quadrant will give you root 2 over 2, and then sine of 3 pi over 4, which is in quadrant 2, will also give you root 2 over 2. So clearly it's not a 1 to 1 function because there are two different x values that will give you the same y value. What we call trig functions are that they are periodic, they cycle and repeat. So just as you go through, you go from 0 to 2 pi, and then at 2 pi, you definitely know that those values start repeating themselves again. So we call that periodic. It means they're going to cycle through the same values again. They're going to repeat those same values. So when we're trying to deal with inverse trig functions, we are going to have to restrict the domain so that we can make it a 1 to 1 function. So that way we won't have multiple values in the domain that will give you the same value for that trig function. Okay, so we're going to go through sine, cosine, and tangent, the inverse functions for each, and talk about what the restrictions are. We'll do some examples so you can see how it's done. So we'll start with the inverse sine function. So u equals sine inverse of v. Now in terms of the domain of the inverse sine function is going to be between -1 and 1, including -1 and 1. And then the range, this is the one that we're going to focus most of our attention on today. The range, so the output of your inverse function, is going to have to be between -pi over 2 and pi over 2. Okay. Another way to write this, if it's helpful to see the inverse sine function next to the sine function, that means sine of u equals v is the same as u equals sine inverse of v. In terms of the picture, the range restricts us to this part of the graph. So we're looking at quadrant 1 and quadrant 4. Okay, so if you're asked sine inverse of a particular value, your answer has to be between -pi over 2 and pi over 2. It has to be something on this diagram here. So let's take a look at an example. So sine inverse of 1/2. Okay, so if it helps, let's just write this out as sine inverse of 1/2 equals theta. We know that theta must be in the interval between -pi over 2 and pi over 2. So we'll keep that in mind. If it's helpful for you, you can rewrite the inverse function the inverse sine function just as a sine function. We just have to move some things around. So this is the same as saying sine of theta is equal to 1/2. So this might look a little bit more familiar to you. Okay, so how do we know what that value is? Well, it is one of those memorized values on that chart I told you had to have memorized. So sine of theta is equal to 1/2 when theta is equal to pi over 6. Now let's just verify for ourselves. Is pi over 6 between negative pi over 2 and pi over 2? Yes, it is. Pi over 6 is in the first quadrant. So sine inverse of 1/2 is going to equal pi over 6. Okay, let's take a look at another example. Evaluate sine inverse of negative root 2 over 2. Okay, again, I'm going to write this out as, okay, this is equal to some value theta, and we know theta has to be between negative pi over 2 and pi over 2. And then I'm going to rewrite this as sine theta equals negative root 2 over 2. Now, remembering that our answer can only be in quadrant 1 or quadrant 4, now let's take a look. We have sine of theta equaling a negative value. When is sine of an angle going to be negative? There are two places, right? All students take calculus, so in either quadrant 3 or quadrant 4, but we can only be in quadrant 1 or quadrant 4 right now. So between quadrant 1 and quadrant 4, sine is going to be negative in quadrant 4. Okay, so we're looking for root 2 over 2. It looks like our answer is, our reference angle is pi over 4. But because we're in quadrant 4, that must mean the value is negative pi over 4. Right? So it cannot be pi over 4 because sine of pi over 4 would equal positive root 2 over 2. So we must be in the fourth quadrant in order to be negative with a reference angle of pi over 4. If the reference angle is pi over 4 in quadrant 4, then our angle measure is negative pi over 4. So our answer here is negative pi over 4. Okay, let's take a look at example 2. Explain why sine inverse of sine pi over 6 is equal to pi over 6 is true, but sine inverse of sine of 5 pi over 6 equals 5 pi over 6 is not true. Let's just go ahead and evaluate both of those. So we'll start with the first one here, sine inverse of sine of pi over 6. We know that sine of pi over 6 is equal to 1/2. So that must mean we are looking at sine inverse of 1/2. Well, sine inverse of 1/2 has to equal pi over 6. And pi over 6 is in the interval between negative pi over 2 and pi over 2. Okay, so that one checks out. So that one is true. Okay, and the second one, sine inverse of sine 5 pi over 6. So sine of 5 pi over 6, if you're using what we did last time, we are going to be using a reference angle of pi over 6. If you need to draw it out so that you can see which quadrant it's in, that's fine. So you are in quadrant 2. And in quadrant 2, we have sine of 5 pi over 6. We have reference angle of pi over 6. So sine of 5 pi over 6 must equal 1/2, and it is positive in quadrant 2. So we end up with sine inverse of 1/2. And now you can see, well, now we actually have the same thing as what we have in the first one. Sine inverse of 1/2 has to equal pi over 6. And because we restricted the domain to being between negative pi over 2 and pi over 2, it cannot equal 5 pi over 6. Okay, so in order to explain why one is true and one is not true, we can say that because 5 pi over 6 is not in the interval between negative pi over 2 and pi over 2, so when you are taking sine inverse of 1/2, it has to equal pi over 6, even though sine of 5 pi over 6 is equal to 1/2. All right. Inverse cosine. So u equals cosine inverse of v. That's inverse cosine function. And then again, the domain restrictions are from -1 to 1. Again, our focus is on the range. So the restriction on the range, it has to be between 0 and pi. Okay, and again, if it makes you feel better about seeing how to go back and forth between the two, u equals cosine inverse of v is the same as v equals cosine of u. Okay, and then in terms of the range being from 0 to pi, for cosine inverse, we are looking at quadrant 1 and quadrant 2. So your answer for any of these inverse cosine functions should always be between 0 and pi. It should always be in either quadrant 1 or quadrant 2. All right, let's take a look at example 3. All right, cosine inverse of 1/2. So again, I'm going to write this as being equal to theta. And we know that theta has to be between 0 and pi. I'm going to rewrite this so that we're not using inverse function anymore. So cosine theta equals 1/2. In the chart, cosine is equal to 1/2. Where? When theta is equal to pi over 3. Now, is pi over 3 between 0 and pi? Yes, it is. Pi over 3 is in quadrant 1. So that is your answer. Okay, let's look at the next one. Cosine inverse of 0. Okay, we'll do the same thing, write this as equaling theta. Remember that theta has to be between 0 and pi. So cosine theta equals 0. What value of theta will give you cosine theta equals 0? Well, let's look at that chart we have memorized. Does cosine equal 0 anywhere here? No, so not pi over 6, pi over 3. But remember, there's another chart that we did fill out. This one. Right, this was when we were working with the unit circle, and we were looking at the far right, the far left, the top, and the bottom of the unit circle. So cosine is equal to 0, where? When theta is equal to pi over 2. Okay, so pi over 2, is that between 0 and pi? It is, so we are all set there. So theta has to equal pi over 2, so cosine inverse of 0 equals pi over 2. That is our answer. All right, we've done sine inverse, cosine inverse. Last one we're going to do is inverse tangent. So u equals tan inverse of v. Our restrictions on the domain are from -infinity to infinity. Again, we are focused on the range, where it's between -pi over 2 and pi over 2. And again, if it's helpful for you to see it written in two different ways, u equals tan inverse of v, or v equals tangent of u. Okay, and then the range being between -pi over 2 and pi over 2, that is between in quadrants 1 and 4, just like with inverse sine. All right, we have one more example. Evaluate tan inverse of 1. Okay, so tan inverse of 1 equals theta. Theta has to be between -pi over 2 and pi over 2. So tangent of theta equals 1. Look at the chart. Where is tangent of theta equal to 1? When theta is equal to pi over 4. Is pi over 4 between or within quadrants 1 and 4? Pi over 4 is in quadrant 1, so that's going to be our answer. Tan inverse of 1 equals pi over 4. All right, that's all we have for today.